Hey guys, it's Tim from MVP Machine. Today we're going to be talking about feeds and speeds for your Suburban Tool Fly Cutter. And for the 3 different bars that are available, I'm going to give you some baseline values and then how you adjust your spindle RPMs and your feed rate when you change the, the length of the bar or in between bars. What you're seeing in front of you, we have the range of each bar, and it tells you basically the 5-inch bar, you've got a range of 5 7/8, and adjusted to its largest diameter is 7 3/4. Then for the 7.5-inch bar, you've got 7 3/4 to 10 9/16 cutting diameter range, and the 11-inch bar is 10 9/16 to 19 inches. And I'm going to show you how you adjust when you adjust that bar size, and we'll look at the baseline values as well. Please be sure to like and subscribe in case you need to reference this video in the future, and also feel free to comment and ask questions below in the comment section. What you see here is the spindle speeds and feeds for mild steel. And in mild steel, there's a maximum cut depth of 30 thousandths of an inch. And I don't usually go that deep in mild steel, especially if you were using the 11-inch bar on a Bridgeport. You just have to, adjust accordingly. If that bar was set to 19 inches on a Bridgeport, you're not going to want to take 30 thousandths of an inch. So, a lot of people use this tool for debarking hot rolled steel, and it does a beautiful job. I usually take about 15 thousandths depth of cut, but what you're seeing is the baselines on the feeds and speeds. On the 5-inch bar, you would start out with it set to the smallest diameter at 820 RPMs and 7 inches a minute. The 7.5-inch bar at 720 RPMs and 6 inches a minute, and the 11-inch bar at 550 RPMs and 5 inches per minute. Okay, at the top right, we have in green, it basically says for every 1 inch the bars are extended from the minimum diameter, subtract 7% from the RPMs and 7% from the feed rate. So basically, if we applied that to the 5-inch bar, was it set all the way in at 820 RPMs, if we pulled that bar out 1 inch from that point, we would subtract 7%, which would be roughly 760 RPMs, and also 7% from that 7 inches per minute, and that would be 6.5 inches. So that applies to basically all materials and also all of the bars. So every 1 inch you extend it, subtract 7% from feed and speed. Now these feeds and speeds that I'm giving you today, you might notice that they contrast with what you received with the tool. On the back of the safety document that comes with the tool, there's a chart for feeds and speeds. And this is just an updated, we'll be updating that sheet soon. I work with this tool pretty much every day, and over the last 12 years or so, some of those values have changed just based on observations. And this tool is very forgiving as far as feeds and speeds go, so you don't have to, some machines may, depending on the condition of your spindle or the tram of your machine, or I should say how well your machine is trammed, a certain degree of variation from what I'm giving you here may work better for your situation. Quick tip here, most people are used to using coolant or cutting oil, and for this tool we don't recommend it for any material. There's no situation where it will help your finish or help with insert life. So coolant and cutting oil will actually negatively affect your finish, and it will also negatively affect insert life. So not necessary for this tool at all. The heat comes off with the chip. Okay, here we have the feed and speed values for aluminum. I'm showing you 6061 aluminum. It's the most common alloy that we run across anyways, but and as you can see, the values are considerably faster, and you have a maximum depth of cut in aluminum of 0.1 inches, but use caution until you're familiar with how these cut on any machine, and also use caution getting up to these RPMs. On any machine, when you receive this tool, you should try out the bars and see what RPMs are safe, and never start up your spindle on a high RPM with this tool in the spindle. It's an unbalanced tool and it can cause problems. But also on aluminum, the same 7%, and actually, as I said before, on every material you subtract as you as the bars grow in length by 1 inch, you subtract 7% on feed and 7% on speed. Okay, you can see here that we have a list of all the materials that this tool will cut, and I'm sure I've left some out. I've personally cut all of these, and I'm going to just run down the list briefly and tell you how I would apply the feeds and speeds to each material. Okay, we've already covered the mild steel, which is hot rolled and cold rolled. We've already covered aluminum. When you get into brass and brass alloys, typically I go about a blend between the two, halfway between mild steel on your RPMs and halfway between mild steel and aluminum on your feed rate. On the cast aluminum, I pretty much run that at the same speed as normal aluminum. Sometimes it's a little more abrasive and it may be beneficial to slow down your feed rate and your RPMs a little bit. And now when we get into cast iron, there's kind of a mixed bag of cast irons because they can be a variety of different grades of cast. You can have meionite, but for like a standard cylinder head, I would recommend using the same feeds and speeds as mild steel. Now when you get into your mold steels like P20, 4140 preheat treat, you'll want to slow down both speed and speed from the mild steel numbers by approximately 20%. For your plastics, this pretty much just going to apply for plastics, acrylics, nylon, UHMW, and even for the wood. You can pretty much use the same feeds and speeds for aluminum, and they are all pretty forgiving as far as the feeds and speeds go and cut very freely with this cutter. And then some stainless steel you can use with this cutter, some you can't, and most of the free cutting, the leaded steels, leaded stainless, works perfectly fine with this cutter. And like I said before, I'm sure there's some materials that I've cut on this and I've left out. If there is material that I've left out, just leave me a comment below and I'll take my best guess at it. Or if I've cut it before, I'll tell you what I think you should use for feed and speed. Well, that's going to pretty much wrap it up for this video. I hope you guys found this information helpful, especially if you own this tool. If you don't own the tool, there'll be links below. It's available from subtool.com and from eBay. And thank you for watching. And please remember to like and subscribe, and feel free to comment and ask questions.